Okay, thanks everyone for joining me. So I'm Chung from Durham University. In this talk, I'll just give you kind of like a taste of running Umbridge applications on classical HPC systems that you may have access on perhaps as a part of your university's infrastructure. Okay, so here's the outline of my talk. In the beginning, I'll just give a really brief, perhaps a too short crash course on using HPC systems. And after that, I'll move on to our load balancer implementation and how that, I guess, integrates with HyperQ. And I'll talk about HyperQ a bit more later. And finally, I'll just also give a quick and short demo on using our load balancer setup and conclude the talk. Okay, so right. Similarly to cloud computing, you usually don't have direct physical access to supercomputers like you have on your laptop, desktop, whatever. The way you get access to them is through SSH. It means secure shell, provides an encrypted channel that connects your terminal onto the remote machine. And the way you enter the command is something just like SSH, your username, and then IP of the remote machine. Obviously, I've skipped a lot of details because you need to provide like encryption keys or whatnot. But anyways, there's also a similar command called secure copy to move files between your host machine and a remote machine. And yeah, lastly, because the supercomputer is shared by perhaps more than 100 people, that you don't get exclusive access or perhaps rights to the resources by default. And these things are handled by schedulers, which I'll also talk a bit more later. Okay, to the next slide. Right, and because these file systems shared by all the users of the system, you usually don't get sudo or also known as admin rights as a typical user. And as a result, to use some packages or even tools, say Python, netcdf, FFTW, these kind of things, you either have to go through the so-called module system that is installed by the system admin, or alternatively, you can go the long route and build it from source, which I guess grants you the ability to cherry pick the version that you like, but it's a hassle. And usually using just the module system is sufficient. So what the module system does is set up the environment variables in your path so that when you type a command in the terminal, it will be recognized. So things that you could set up using the module systems, perhaps like compilers, GCC, Fortran, or even npm packages, Python, MATLAB, this kind of thing, so on. And just for interest, I guess, you can still type in sudo, as a normal user, but this is what I get as an output when I try to do it. So this is my username. It is not in the sudoers file, so I'm not part of the system admin. It'll be reported, but I haven't got into trouble. So yeah, so far so good. Yeah, okay, so the next slide. Okay, so I've mentioned how the resources within HPC systems managed by schedulers, what they do is to implement a batching system where you can submit your so-called jobs to these schedulers where they'll be put into a queue. This means that your job do not usually run instantaneously. Well, it depends on how much resources you are requesting, right? So if you are requesting like half of the machine, then well, good luck. You may need to wait for like half a year or maybe even longer. But the point is that the moment when you submit the job, it does not run immediately. It goes through the scheduler's scheduling algorithm that decides the priority of your job. There are several popular options available on typical HPC systems, Slurm, PBS, LSF. But for this talk, I'll just mainly focus on Slurm. And this is how an example Slurm job script looks like. You put in your shebang, the shell. These aspect, I guess, keywords are passed on to Slurm. So for example, this command specifies the job name, and this one specifies the name of the output, the error, and so on. So this -p stands for partition. So in a HPC system, the resources are kind of presented in nodes, and some of these nodes are categorized into, I guess, a special partition, hence the name. And in this case, it is just the task queue of the particular node I'm using. And yeah, this sets the time limit, how many nodes I'm requesting, how many CPUs I want for my job, and so on. And the rest of this is just typical bash commands. So here I load my compiler, compile it, and run the executable. And yeah, this is the command to submit this job script into Slurm, where it will get put in the queue and then run when it decides that you're lucky enough. Okay, so Linus has given an overview of the cloud computing, and I just wanted to kind of give a really broad overview, I suppose, on how HPC compares to cloud. So in HPC systems, users have started to adopt containerization technologies to provide portable applications, because as I mentioned earlier, you typically do not have the power to just do a simple installation. Yeah, sorry about that. Just through apt-get install or whatnot. And through containerization, you can package everything, every dependencies you need into that container and deploy it into different systems, just for the ease of usage. And in cloud systems, there's also, I guess, a trend that is kind of attracting HPC users. And this means there's some kind of middle ground where these two paradigms are, where these two paradigms are somewhat meeting. Yeah, so in the cloud, we use Kubernetes to orchestrate the containers and having a load balancer to distribute the client requests into the parallel models. Whereas in the HPC system, we'll use Singularity instead for various security reasons instead of containers. And what we'll do is to launch Slurm jobs from the login node. And additionally, we need to have our own load balancing solutions through HyperQ, which again, I'll talk about more, HyperQ more later. And yeah, so this is what we want to achieve basically. We want to have kind of a cloud analogous HPC solution to run Umbridge. We want to scale up Umbridge models for UQ problems while keeping the whole UQ process simple. So avoiding the machine-specific setup that is done through containerization and having multiple parallel instances of Umbridge models. We can do that through the custom load balancer, and well, the load balancing part will be done by the load balancer and as well as HyperQ or Slurm. Okay, so HyperQ is an application I believe developed by the Czech Supercomputing Center. It is kind of a plugin scheduler that works on top of Slurm. So it does not replace Slurm in a sense, but rather it works in tandem with it. It does not require admin privileges, so that's really nice for HPC applications, and it's available as a statically linked binary, so you just need to download the executable from the GitHub and can run it straight away immediately. What it does is deploy a server where the users can submit jobs to the HyperQ server rather than to Slurm, and then it will distribute these jobs into the compute nodes that it requests from Slurm. So this is how the pipeline goes. Like, suppose you have the HyperQ server in the login node where you submit jobs, and then HyperQ receives the HPC resources from your scheduler, and it will deploy and distribute these tasks into the compute nodes. Or as a HyperQ worker, I should add. And this is a similar schematic to what Lina showed earlier in the cloud computing setup. What we had was a parallel UQ client that connects to the load balancer via Umbridge, and in turn, Umbridge connects to HyperQ, and HyperQ connects to our HPC resources through our scheduler. So the load balancer acts as kind of a middleman between the scheduler and the client. To the client, it acts as a server, but to the server, it acts as a client. It basically just forwards model evaluations towards our Umbridge models. And because it is not a compute-intensive process, it can run on the login node as well, but obviously you're also free to run it on the compute node. We provide two backends to this load balancer. We have a Slurm backend where it's easier to set up, but comes with a slightly higher job overhead for quick running jobs, say jobs that last for less than 10 seconds. Whereas in the HyperQ backend, it is slightly more, well, it's not slightly more, but it is quite significantly more powerful because it has a really flexible tasking mechanism where it allows you to kind of simulate a Slurm job array, but with more flexibility to decide how many resources that you allocate to each of these jobs. And the way you use the compiler is to, the way you use the load balancer is to first compile it with make, and that is included, and the make file is included in the Umbridge repository. And you can execute the load balancer binary with this command. Okay, this is just how the load balancer Slurm script looks like. It's very similar to excuse me, the typical Slurm job script I've showed earlier. You have this partition keywords requesting how many tasks you want, and then the time limit as well. Within this script, there are many other functions that searches for free ports in the compute node, but those are the things that you don't need to worry about. What you need to change basically is this command where we have put a comment here. You just need to replace this with your Umbridge model. And here is the HyperQ version. in addition to the Slurm script, we have another, I guess, hypercube server script where you specify the resources that you wanted to request from Slurm. So here we request a time limit for the server and an idle timeout where if there's nothing going on after 3 minutes, then the server shuts itself down. And anything after this double dash is passed on to Slurm directly. So this is the job script where you specified your Umbridge model. And notice how the Slurm SPatch, the SPatch keyword's been replaced with hypercube. It's basically the hypercube equivalent of the Slurm keywords. But then again, what you mostly need to worry about is to change this line to your Umbridge model server. Okay, now I should probably give a quick demo on how to use the load balancer backend. I'll just change the screen. Okay, cool. Yeah, I'll get rid of these two because I don't need them. So here I'm in the Umbridge HPC directory where I have the load balancer executable. And as I've shown on the slides, I specify my scheduler at hyperq and then what port I wanted it to run on. So it can be anything, so 5674. I run this, and now there are several outputs shown on screen. The hyperq server has requested 2 workers, that is 2 nodes from Slurm. And if I do a simple sq command here, you see that it has this Slurm this hyperq server has this Slurm job ID with 2 nodes requested. And what I need to do now is just to connect my client to it. And I'm running this in a parallel way where I have 2 threads to submit the client requests. So 5674, and then I'm using, oh, and by the way, I'm using the example model and client that's come prepackaged in the repo as well. So have it in test. Client. So the first few jobs are error checking process, so you can basically just ignore them, and there's an option to turn it off as well. But here, as you can already see, my job is basically multiplying the inputs by 2, and it's done it in a parallel way where I have 2 model instances, and I have a parallel client where it forwards these parallel requests to the models. And okay, I'll go back to the slides. Yeah, and just to summarize, we can use Umbridge to couple complex simulation software to any UQ packages in, well, as mentioned by Linus earlier, many different programming languages. And it has a rather simple parallelism support with the load balancers that we have tested on multiple applications. Though I should emphasize that the HyperQ backend, though the core features are already up and working, there's still some features that we'd like to implement and improve on. So please let us know if there are any issues or any features that you'd like to get included in the software stack. And yeah, it's an open source project, so contributions are always welcome.